Today I will be showing where an action potential is transferred from a motor neuron to a muscle fiber. This area is called a neuromuscular junction. The neuromuscular junction is a synapse between a motor neuron and a muscle fiber. First, let's take a look at the parts of a neuromuscular junction that are associated with a motor neuron. I drew out the steps, but first we're going to look at step 1 to look at the parts of the neuromuscular junction. The first part is called the axon terminal. The axon terminal is the end of a motor neuron. The membrane of an axon terminal is called the presynaptic membrane, which is this highlighted area here. At the axon terminal, you will find the following structures. The first structure is called the synaptic vesicles. The synaptic vesicles are filled with neurotransmitters. A neurotransmitter is a chemical messenger. Also at the axon terminal, you will find voltage-gated calcium ion channels. Voltage-gated calcium ion channels open in response to an action potential. Surrounding the axon terminal, you will find free-floating calcium ions. At the end of the axon terminal, there is open space where a neurotransmitter diffuses across, called the synaptic cleft. Next, we will look at the parts of the neuromuscular junction that are associated with the muscle fiber. The area of the muscle fiber where the motor neuron synapses with is sometimes referred as the motor end plate, but here I'm going to call it the muscle fiber. The first part of the neuromuscular junction associated with the skeletal muscle fiber is the sarcolemma, which is highlighted in green. The sarcolemma is the cell membrane of the muscle fiber. On the sarcolemma, you will find chemical-gated sodium ion channels. The chemical-gated sodium ion channels open in response are in the presence of neurotransmitter. When a neurotransmitter binds to a receptor on the chemical-gated sodium ion channel, the chemical-gated sodium ion channels will open. Within the synaptic cleft, you will find free-floating sodium ions. Okay, well, we're going to look at the whole picture of the steps. So let's look at the steps at the neuromuscular junctions during a muscle contraction. The first step, an action potential travels down to the axon terminal. Step 2, the action potential stimulates the open of voltage-gated calcium ion channels, and when open, allows calcium ions to diffuse into the axon terminal. Step 3, calcium ions in the axon terminal then stimulates the synaptic vesicles to fuse to the presynaptic membrane of the axon terminal. By fusing to the presynaptic membrane of the axon terminal, synaptic vesicles are able to release the neurotransmitter into the synaptic cleft. At step 4, the neurotransmitter that diffuses across the synaptic cleft binds to the receptors of a chemical-gated sodium ion channel. At step 5, the binding of the neurotransmitters to the receptor causes the chemical-gated sodium ion channels to open. At step 6, the sodium ions diffuses across the sarcolemma, creating a new action potential within the muscle fiber.